Negative 3 pi over 4 is the same thing as saying negative 135 degrees.
So you go back.
So I start at 360 on the unit circle and go backwards to 225 because that's minus 135. Is anybody confused by that? Starting at that step. Speak now or forever hold your peace.
Cool.
Okay. So I need my ordered pair at 225.
Oh yeah.
So does anybody remember what that one is?
No way.
225 is a 45, so it's root. It's 5.
No one remembers.
So 5 root 4. Oh yeah.
No one remembers.
It's negative root 2 over 2, negative root 2 over 2. How many of you would want, from here, once you get the point, all you got to do, the x value is that one. That's your cosine. That's all there is to it. It'd help if you wouldn't. Do what?
We're supposed to find all 6 of them.
Right. Sine is just the y value. Correct. Then the tangent is y over x, which is negative root 2 over 2 over negative root 2 over 2, which is just what? 1. And then, for the other 3, all you got to do is flip the other ones. You don't have to rationalize the denominator. Secant goes with
Sine.
cosine. So I flip it. Now, when I flip it, I keep the sign.
Why are you keeping this on?
Because it's the reciprocal. Reciprocal doesn't change the sign.
I thought it did.
No.
Put it on.
Not if they know what they're doing. Alright, oops. Cosecant theta is the same. You just flip.
Why is tangent 4? Is that 4 over x?
That's a y. Sorry.
Oh. I don't understand. Okay.
Cotangent, yeah, because if I write 1 as 1 over 1, if I flip it, it's just still 1 over 1, so it's just 1.
Oh yeah.
So does anyone have any questions about it?
Wait.
It'll tell you to use the period as an aid, actually. It won't say reference. But all that means, if when you see that problem with those directions, take 8, divide it by 3. Alright, all I'm worried...
Only when you see those directions?
Do what?
Only when you see those directions?
On this, yeah, for your test's sake, yeah.
It'll say what now?
It'll say use the period as an aid. There's only going to be one problem like this on your test. All I'm worried about is the remainder, though. All I'm worried about is the remainder. And that's going to be the new numerator. So I want to have the sine of negative 2 pi over 3. So from this original problem, the only thing that changed was the 8 changed to a 2. So whatever problem you have, this number here is going to change to whatever the remainder is. Every time. So once we found this, alright, now it's just like this problem over here, except we've only got to find the sine. We don't have to do all 6 of them.
Oh yeah.
We only have to find the sine. So I got to figure out which angle to look at for negative 2 pi over 3.
It's a 60-degree angle.
It is a 60-degree angle, but
It's in the third.
so negative 2 pi over 3 is the same thing as negative 120. So I need to look at what angle? Look at 240.
240.
Wait, why were there 240?
Right, because this is negative 2 pi over 3. So I need to go backwards on the unit circle. Since negative 2 pi over 3 is the same thing as 120. Negative 120. If I go backwards 120 degrees, I'm at 240.
So that's negative half. Negative.
I have no idea what you're talking about.
We're trying to find sine, so we only need to look at the y value. And so it's negative root 3 over 2. So the two things that you'll need to write down for sure on the test is I need you to show me this at some point. Show me that you're looking at this angle, and then the answer. All right? Does anybody have any questions? Draw a triangle. Start in the origin every time.
Bottom left.
And it's going to be in the bottom left. Come out. When I connect it, connect the triangle back to the x-axis, always. Always connect the triangle back to the x-axis.
Oh no.
Well, I do. And then the angle that I look at, I want to look at the angle closest to the origin. The angle close to the origin inside the triangle. That's going to be my reference point of this angle. Then I got to figure out what side of the triangles to label. So the cosine in SOHCAHTOA is what? Opposite over hypotenuse. Oh. That tells me that it's -4 over 5.
And then the other one's 3.
So the adjacent side is -4, hypotenuse is 5. Alright, so then I can label these -4, 5.
The other one's 3.
The other one's going to be -3 because it's in the third quadrant. So both legs are negative in the third quadrant. Then I just have to do all the SOHCAHTOA stuff, so that's -3 over 5.
Oh, we're going to have to do
All 6 of them, yes. It's tangent's -3 over -4.
If we didn't know the other leg, how would we figure that out?
Pythagorean theorem.
Oh, if I go back there, I forgot.
Yeah. Then the other 3 trig functions, all you have to do is flip those 3. Alright? And I mean, we'll do that if you want to, but I mean, I'll write it down if you want to, or we can just go on to the next problem. Does anybody want to see those 3? All you do is flip the fractions. When I flip them, it still stays negative.
Why did you put -3 over 4 and 3 over 4?
Because it's -3 over -4, which makes it a positive 3 over 4. Negative over. What that's asking me to do is take the tangent. All right, I want to look at all the angles on the unit circle, or if you've got to memorize, look in your brain and figure out what angle gives me a measure of √3 for the tangent. 30? Well, the tangent's y over x. So if you looked at the 30-degree angle, it's 1/2 over √3 over 2. If you do the ear, you'd get 1 over √3. 1 over √3 is not what we're looking for, so it's not 30. The 45 would give you 1, so it has to be the 60. So it's the 60-degree angle. The only other thing that you have to look for is that this is a positive tangent, right? There's another angle that'll give me a positive tangent of √3. What would it be? 300 is in the fourth quadrant. One of those is positive, one of those is negative. So positive over negative, or negative over positive gives me negative tangent. So I need the one in the third quadrant that gives me negative over negative, which is what 60-degree angle's in the third quadrant? 240. Or these are pi over 3 and 4 pi over 3. I don't care. I don't care which one you write it in.
So if we have a problem like this and it doesn't specify which quadrant, we just have to do one, we have to do both.
It'll tell you, it'll tell you from 0 where theta, sorry, not x, where theta's from 0 to 2 pi. And that means all the way around the unit circle. So you've got to tell me both angles.
So we're just telling both angles?
Tell me what two angles give me a tangent of √3. So I need to know that this right here is what I'm looking for.
So that's the answer?
Yep.
That's it.
You don't have to put all 4. Either put both of them in degrees or both of them in radians. It doesn't matter to me. Which
So
one?
you just do one to the middle.
You just unzoom it. I can't unzoom it.
Is this 4 pi over 93?
Okay, that's what I understand.
Alright. So it gave you what's in green there in the problem.
Yes.
Alright. Then I want to take the inverse sine of both sides. So I'm going to take the inverse sine of this. Just like if it was...
So why did we just leave it, the one you brought it down, you didn't change anything, you just took the sign away, is that what we're trying to do?
Yeah, we want to take the regular sine away and then have an inverse sine.
Why do we just take one away and then put another one
Because this is inverse, not regular.
in? Alright.
I don't know why they want you to know this, but there you go.
Thank you, dumbass.
That's true. Okay, so I can change. Look, this is important. Over here on the right, I have a cosine, correct?
I don't know what that is, it says C-O-L.
It's hard to write with this thing.
Can you not put your hand on the thing? It'll start writing, right?
Right. Okay, so the answer's in cosine. I have a sine squared here. I have a regular sine here. The only oddball is kind of cosecant, so I can change. I need to change the cosecant to what? 1 over sine. So 1 over sine times sine minus sine squared.
Man, look, watch. I knew it. Yep. All pop up.
So those cancel out because it's multiplication. All right, so that's 1 minus sine squared
I mean, I didn't even write this problem down.
equals cosine squared. Okay, is anybody wondering where I got any of this from? The 1 minus sine squared, I have to do something with this formula over here. The sine squared plus cosine squared equals 1. I can minus sine squared from both sides of that,
Oh yeah.
and it's going to tell me that cosine squared theta is equal to 1 minus sine squared theta. So I can just plug that in. And there I go.
We gotta remember to keep that one though. What is it? Full out.
Fulled out is going to be 1 minus secant squared. But you can full it out, it'll still get the same thing. Alright. Here, this fraction over here, what did I multiply it by on the bottom so it looks like this? What is it has it doesn't have the 1 plus secant. So 1 times 1 plus secant is 1 plus secant. This fraction has a 1 plus secant on the bottom, so it's missing the 1 minus secant. So I multiply the bottom by 1 minus secant, I get this. Then multiply the top by 1 minus secant. Right? Since this fraction's a plus, it's going to be plus 1 minus secant theta. Alright, so anybody confused on where any of this comes from so far? Be very similar to the problem you're going to have tomorrow on your test.
So the answer is what?
We're not done yet. Okay, so from here, what we need to do, is simplify everything. Secant, see how this is plus secant, this is minus secant. And since this is all addition or subtraction across the top, I can just cancel those secants out. That leaves me with, I got 1 plus 1 left on the top. I've got a 1 here and a 1 here, so I've got 2 on the top. Then when I full that out, I get 1 minus secant squared theta. Alright, then, yes. 1 minus secant squared theta. Alright, over here, tangent, it's going to be, but when I rearrange this to subtract 1 from both sides, I can't. That gives me secant squared minus 1. I need 1 minus secant squared, so the tangent's going to be negative instead of positive. You've got to rearrange it so it's 1 minus secant squared, not secant squared minus 1. So you would get 2 over negative cotangent squared theta. And cotangent, if I flip cotangent up to the top, it's what? Wait, that's supposed to be tangent, not cotangent. Sorry. Should be tangent. Flip it up to the top, and I get cotangent, which is what I wanted at the end.